Hey there, Dino. And today I want to talk to you about MCP, Model Context Protocol, described as an open protocol that standardizes how applications provide context to LLMs. I don't think that quite captures it, not the way I think about it. The way I think about it is it's the protocol that agents, what we used to call chatbots, use to talk to external resources or systems that they want to include in the dialogue that they conduct with the remote large language model, like a Gemini or an OpenAI. So the agents in this case, is things like Copilot or Claude or the new Gemini CLI. I don't know if you saw the news about a month ago. Google announced Gemini CLI, which is a command line tool. You can run a Gemini chatbot in a terminal. That's another example of an agent or built-in agent. So that's um, how I think of what MCP is, the way these things talk to systems that they want to include in this dialogue with the generative models. There are different transports for MCP. The two big ones are standard I/O and HTTP with streaming. So the standard I/O is going to be used for what are called local MCP servers. The client, in this case, the agent, Claude or Gemini CLI, can launch an MCP server. It's called a server, but really it's just a local thing. It's not a shared remote server. In this case, it is a server. It serves requests, but only for that one chatbot, only for that one agent. That's what you would use standard I/O for. So you could have I don't know, an MCP server that would access your file system or turn on the lights in your house or do something else that's related to the system or directly connected to the system on which you're running the agent. Remote MCP servers are maybe a little bit more interesting. They're more general purpose and they can be shared. Um, MCP is based on JSON RPC. I won't go through too much of the specification, but JSON RPC is a long-standing spec. Let's see, when was so version 2 of the JSON RPC specification was originated in 2010. Most recently updated 2013. It's been around for a long time. It is a way to describe RPC in a JSON format, just according to these kinds of standards. So this is a request. This is an example of a response to that request. Key thing you want to catch here is that it's JSON and the entire context of the request is in that JSON payload. So unlike REST, where you have a verb and a URI path, and those constitute part of what is being requested remotely. The HTTP verb and the HTTP path have meaning in REST. In JSON RPC, they don't. All of the information associated to the request is is encoded in the JSON itself, and that means you can transport it over anything. Standard I/O is just one example of a verb-free transport. You could send it over TCP. You could. You can send it over HTTP. If you're doing it over HTTP, it has to carry this payload, so it's always going to be a post. Um, but that's sort of irrelevant to the purposes of JSON RPC. The method is described there, and the parameters are just encoded there, so nothing in the URI path and so on. So MCP is a use of JSON RPC. But as I said, it can be transmitted over HTTP. And for the rest of this conversation, I want to show you some examples of how that might work. So I've put together an MCP server implemented in Python. So this is a custom server. It does some things that I wanted to do. It basically wraps some existing systems. An OpenSky network has a flight activity API that I can query. That is a RESTful API. But basically, I'm putting an MCP wrapper on it. The reason I want to do that is because these off-the-shelf chatbot tools like Claude and Copilot don't necessarily have the ability to understand what REST endpoints are and how to navigate them, but they can use MCP to navigate systems. And so we'll put this MCP wrapper on these existing APIs, and that allows those off-the-shelf tools to be able to take advantage of the capability. So I won't go too much into the Python code. It's just kind of standard stuff. You use this fast MCP module, which is pretty popular and pretty easy to get an MCP server stood up, and I can run it right here on my local system. So when I start this up, it'll say, hey, MCP, that fast MCP is running. It's listening on this port. And I can configure that in the settings for my local Gemini CLI. So I have a chatbot or agent that runs locally, and I'll open up another terminal window and I can run that. So it will start up and it's telling me just as a status, hey, I got 2 MCP servers and I can have a look at them. These are 2 that I registered for Gemini separately in the settings file, and this is the one that I was just showing you with all the description, all that documentation that I showed you in the Python code. It's coming through to the Gemini agent. So now, if I make queries to this agent, and those queries need information that could be provided by this MCP server, then Gemini will invoke the MCP server to get that information. Let me show you how it works. I'll paste in this query. Of the flights being reported currently for the Chicago area, produce a report of the count of those flights per airline. And you can see as soon as I typed that in, Gemini came back and said, hey, I think I have a tool that might help with that. Will you give permission for me to use that server? And I granted permission, and now it's invoking it. And this is just sort of progress update on what it's getting back from that server. And then it's going to aggregate that all into a response of the form that I asked. Okay, it looks like it's translating the call signs into airlines, and there's a table. So for the flights that were currently active around Chicago, 15 of them were Southwest Airlines and so on down the list. So pretty neat. Using that MCP server, if I go over and look in my terminal window, I can see there's a bunch of log messages of that server responding to all the requests that Gemini was sending out. So interesting enough. We can go a step further, though. It's possible for me to run this Python code in a container inside a container runtime, like something called Cloud Run. So that is something you may be familiar with. It's a container-oriented serverless platform. I've got flight stats deployed into Cloud Run, and I can, manage it as that remote service. It's available at this endpoint, and I can see the logs and everything for that service. It's the same system that I had running locally. How can we get Gemini to talk to that remote service rather than the one running locally on my machine? Well, to do that, we need to update the Gemini settings file. This is what the settings file looks like when it's connecting to that local service. I can change that and stipulate that remote URL and allow Gemini to talk to the remote service. So let me save that. Flip back over here. We'll start Gemini again, and it's going to connect again to the MCP server. And it will now be able to use that remote server to help it answer queries about flights and so on. So we'll try maybe a different query. How about compare the volume of aircraft flights currently in the Chicago area to the flights in Seattle. Where are more flights flying currently? I don't know if that's a good way to ask, but there's my prompt. Gemini, again, is likely to see the flight stats tool and say, hey, I think that can help answer this question. So again, it asks the user for permission to invoke this tool, and I granted permission. You can see the progress, and it's now invoking that remote Cloud Run service. And it's saying, hey, right now, there are more flights reported in the Seattle area than in the Chicago area. Okay, great, interesting. All of that is good too, but what you're seeing now is this is just Gemini connecting directly to a remote Cloud Run service. And you can imagine there could be lots of Geminis or other agents running in a company or in an audience, and you might want to manage the traffic into these things. This MCP server is listening on HTTP, and it's not a RESTful API. However, it is just an HTTP-based API, which means you can manage it with the tools that you already have at your disposal, including things like Apigee. So another option we can do is stand up an Apigee proxy between the agent and the MCP server endpoint, which is exactly what I did here. So I've got an API proxy, fairly simple, doesn't do much. It is mostly a pass-through proxy. With MCP, as I said, the path is not that important. The verb is not that important. It's basically just going to be a post all the time to the same path. But we might want to either inspect the payload, or we could do something really basic like verify an API key. So I attached a verify API key policy to the preflow. It's going to look for an API key in the request header and only allow requests that provide an appropriate API key with the right API product and so on and so forth. So how can we do that? Let us go back. We'll, again, quit Gemini. I need to reset the servers. So we will point to the MCP server that is hosted in Apigee. You can see it's a different URI, and I do need to pass that API key. I need to tell Gemini to pass that API key with the outbound request headers. So we'll save that. We'll restart Gemini. And ask a new query. Can you give me a summary of the flights currently active in Seattle, grouped by airline and sorted by the number of flights per airline? I don't know if that's a good prompt or not, but usually these large language models can figure out what humans want when we ask these kinds of questions. Again, it is asking for permission. It is now connecting to my Apigee endpoint in front of the MCP server. You can see it's still reporting that it's doing the same thing that it was doing before. You can't really tell that it's not running on my local machine or not connecting directly to Cloud Run. It's actually connecting through that Apigee endpoint, which is awesome, because now we get to institute all the kinds of API governance that we would want to institute in an enterprise API. That can be credential management, rate limiting, routing, the API product concept, and so on. Now you can see I flipped back over to the debug panel in Apigee, and you can see it's got a number of different calls that are coming in from the Gemini CLI asking questions. And if I want, I can use this debugger to have a look at what the request looks like. So this is the initial call. is an initialized call. So this is a JSON RPC call coming from Gemini to the Apigee endpoint, and then eventually to the MCP server that's running in Cloud Run, saying I want to initialize. The next call is a response or a statement to the server that the client is initialized. And then we start to see, hey, I want to know what tools you have available. So it's querying. Gemini is querying the endpoint. And then it starts to actually use the tools based on the query that I sent. It's doing a tools call. So it wants to um, map Seattle into latitude and longitude, and we can see the response that comes back. This is the JSON RPC response that comes back from the MCP server that I showed you a little bit earlier. And then it's doing some other work. It's sending in another JSON RPC. Give me the flight activity for that lat long, and here's the flight activity that gets sent back. So we're getting all the Apigee goodness coming right out of Gemini CLI. We didn't have to change anything in Gemini CLI except point it to a different endpoint. And that means, we can manage this API traffic just in the same way that we could with a SOAP call or with a REST call or with a GraphQL call. And I think that's the main point, is that in the world of agentic computing, agents will be connecting to lots of different things. They'll use generative models. They'll use an API to connect to that. They're going to want to connect to enterprise services, maybe directly via APIs, maybe other agents via this A2A, maybe to MCP servers over MCP, which again is HTTP. This layer needs governance. This layer here between agents and the rest of the enterprise needs governance, and Apigee is an excellent tool for facilitating that. So that's the kind of the main thing I wanted to leave you with, the main point, and I wanted to show you what you can do with Apigee today with your MCP servers. In general, I think MCP is pretty fresh. There have been some criticisms of MCP, specifically around the security capabilities, around the use of OAuth. It's getting better, but it's still a journey. It's not quite ready. There's some gaps maybe with the current standard, but Google is investing in MCP on the steering committees, participating in the dialogues, helping to expand the specifications and correct them where we think they need to be, participating in that industry conversation. We think it's a bit early to be embracing MCP as an enterprise-wide standard. Now you can, but you kind of have to maybe delete or eliminate some of the parts that maybe are not so secure. And you got to be careful even when you do deploy it. For now, if you would like to build agentic experiences, I would say a good path to go forward with is to use maybe a custom agent framework where you can build your own agents. So you don't necessarily have to depend on the pre-built agents like Claude or Gemini CLI or Copilot that's already built for you. You can build your own. And Google, in fact, has a great set of investments around that, including we'll call it the Agent Development Kit, or what people are calling the ADK, which is a set of libraries that allows you to build your own agents, custom agents, and you can plug them into all your existing enterprise APIs, systems, services, and resources. All those things do not need to be MCP. So this is a good way to do it, and you can inherit all the network security that you've already built over years and years for all those APIs that exist in your enterprise. The downside is you've got to build your own custom agent. So there is a cost to that. On the other hand, MCP is going to be real. It's vital. It's currently maybe an unfinished state. We're working hard to improve it and to make it enterprise ready. And we think that it'll get there soon. So to the extent that your stakeholders need off-the-shelf agents, you're going to need to embrace MCP yourselves. And you need to figure out how to build and when to build MCP around the systems that you already have. I'm here to tell you that Apigee is already available for you. There's nothing new you need to install in order to be able to manage MCP remote traffic. You don't need a new AI gateway. Apigee's already got the capability built in. It is consistent with all the other management that you're doing for your other kinds of APIs. And after all, MCP over HTTP is just another type of API. So you should be running it over the enterprise leader in API management. Okay, so that's all I got for you today. I hope this has been helpful and clear. I'm interested in your comments and your feedback on this topic. If you got any, please drop them in the comments section below. Till next time, keep it digital.